Good.
Yeah.
Okay, so the recording has started. So can I have the floor?
Sure, please.
Okay, so thank you, Prof. Bright, for the honor of speaking here today. It's really a pleasure to be here with everyone. Thank you very much for attending. I think this was a very excellent session, and I would really like to thank Deborah and Juliet for their excellent presentations. And before I introduce myself and start my presentation, I would just like also to add, apologies if I overlap with previous comments made, but it's extremely important as a scientist to get involved in science communication. And if you are a young PhD fellow, a postdoc, or even a senior scientist, attend workshops on science communication, also how to interact with the science policy interface, because we as scientists, we tend to work a lot in silos. We publish our work in journals that is required of us, but to the general public out there who fund our work, they don't understand our work written in journals. It's too complicated. The science language is too formal, and to build that trust with the public, to share the amazing work that we do, we have to share that, publish that also in the popular media, like Deborah and Juliet mentioned. Also, if you publish your work widely, both in academic journals and in the public media, funders may also see your work, as I mentioned before, the trust in your science may be improved. It's also important that when you work with popular media, you also respect journal policies. That's also very important. And also, when you work with science communicators or journalists, it's important, from what I learned from my own career, it's important to build a relationship with the journalists, also to understand their working environment, their deadlines, make sure there's a clear understanding of what your science means, what your data means, and all of this. So it's important to build that relationship with your communications department, and then also with the science journalist or the science policy arena. So my name is Cloete. I'm a senior researcher, and I'm affiliated to the University of South Africa, and also to ITEMA Labs, the National Research Foundation. So I'm going to talk to you today about my career, my story. And also then we're going to focus the talk also on your career, how you need to prepare for an excellent career in science. Everything, there's a lot of things to think about, because when you're doing your PhD, you focus a lot on the research, publishing, that kind of thing. But there's a whole lot of other skills that you need to build to develop a successful career. Prof, can you go to the next slide, please?
I think you can control it from your end. You actually share it.
Can I? Okay.
Sure.
So I'm going to focus on my career, what type of research I did, why I decided to do interdisciplinary research, a bit of background about myself. And then I'm going to focus on you. I'm going to talk to you about how you build your own career, the importance of mentorship. I mean, this is extremely important, choosing a good and trustworthy mentor that will really invest in your career and help you grow as a scientist. Then we look at the importance of doing a postdoc, deciding whether to stay in academia or go into industry, how you write your CV, how you write your research plan. Also, then I'll also be focusing on your other skill set development, but because of the time constraint, I'll try and touch on everything. So my career, I started as a microbiologist. So why did I do microbiology? Because microbiology is a very wide field. It's very interesting. You can apply microbiology in food. You can apply it in pharmaceutics. You can apply it even in agriculture. And I had at the beginning of my PhD, I had to choose between different types of projects proposed to me. And I found this one very, very interesting because the work had application. And why? I was wanting to work on a medicinal plant. It's a South African medicinal plant, and it's very famous for its pharmaceutical applications, especially the essential oil. It's important for its application in the food industry and also its medicinal properties to heal kidney ailments, stomach ailments. It's also very good for the skin. Now, there's been a trend in kind of popularizing and commercializing this plant, but the farmers that were planting this crop, especially disadvantaged farmers, were really struggling because the soil in which this plant thrives, they were really struggling to establish the plant as a crop, to grow it fast and effectively in these very low nutrient soils. And we were thinking, how can we help these communities? How can we develop something that can help the plant grow? So if you think about a plant, it grows in the soil. In the soil, there's all sorts of things going on. There's insects, there's bacteria, there's a lot of things. And we thought, okay, if we can understand the relationship between microorganisms and how they affect plant growth, that would be a very interesting project. So we specifically looked at soil yeasts. Now you can see in these images here, this is a yeast that is growing on the plant root surface, right? And it was stained with a fluorescent dye. And you can see here, these cells here, that these yeast cells are colonizing this root surface, and it's alive because it fluoresced. This specific stain test for live yeast cells. And here in this light microscopy image, we can see the yeast where they grow. Now this in this specific plant that we used, the yeast were colonizing the outer surface of the root. And we decided, okay, now let's us understand, do the microorganism transfer essential nutrients like phosphorus that helps the plant grow faster? Does it help it transfer the nutrients to the plant? And which techniques can we use then to understand this, how nutrient uptake is affected? And also we looked at plant physiology, carbon economy, all sorts of interactive type of questions that explain this relationship between the plant and the yeast, right? And then I came across with my co-supervisor, he introduced me to colleagues that work in the field of ion beam research. Now, ion beam research is a very wild field that encompasses various type of imaging techniques. Now, this is like a spectroscopy technique that we use to map elements in biological materials. So we prepare the biological materials in a certain manner. We use a specific methodology. Then we introduce it into the ion beam system. And after the experiment is completed, we get an elemental map, a quantitative elemental map that shows us the distribution of elements within the specific specimen that we are looking at. So here we are looking at roots. And here we can clearly see that the yeast colonizing the root surface is taking up phosphorus for the plant. So this shows that this relationship is a symbiotic one. The yeast takes up phosphorus for the plant, improves its growth, while the plant in turn provides the yeast with essential carbon to support its growth. So after I was introduced in ion beam, in the ion beam research field, I got very interested in this because it's a technique that can be widely applied in different types of research fields. For example, after my PhD, we also worked on a project that was looking at coffee beans, and we were actually linking that to toxicology to see if beans from different regions contain toxic elements, and we tried to link that also to the forensic aspect of coffee distribution, whether we can actually distinguish beans from different regions based on their elemental content and also the distribution of the elements inside the bean. So what you see here is a tomography image of the coffee bean, and here is the Pixie maps, the ion beam technique maps, where you can see the distribution of the different elements. So this was a really nice field for me because I could apply it in food research, in plant microbe research, in forensic research. And for a time being, I stayed in this field. But because we have to remember that research funding is dwindling, we have to think about going the interdisciplinary routes. As a young scientist, it's very, very good if you equip yourself with skills in different types of fields. Also, funders are now more inclined to funding interdisciplinary research. Also, it's also important for you also if you can combine translational research with fundamental research. This is very important. So now currently I'm finding myself in the field of nanosciences, and my past experiences were in biology, in chemistry and physics that overlap a bit with ion beam research, very well equipped me to be now successful in this nanoscience field. And nanoscience in itself is a very interesting and very applied field where you can do work in various different fields, apply knowledge from various different fields, collaborate with people from very different disciplines, and it's extremely interesting and hot field. When you also choose a research topic, think of something that can help the public, help communities. How can you use your research to help the wider public? For example, address the sustainable development goals. There's a lot of problems we're facing now also with COVID. And COVID in itself is also, when you look at the research being done, it's becoming very interdisciplinary. So now let's focus still on myself. So what did I learn during my career? It's extremely, extremely important to have a plan for your career. Set out a plan. Choose a hot topic in science. What can you do to help communities, to make a difference? Have a good mentor. This is extremely important. Having a supervisor that is supportive, that wants to see you grow as a researcher, because that is very important in a research career if you want to grow and be successful. Also, choose a subject that you love. You must be passionate about what you do, because science can sometimes be exhilarating and it can sometimes be exhausting. And during those times, you need to have the passion to really get on with it. Make the most of your postdoc. This is very important. Some people choose not to do a postdoc. There's pros and cons to a postdoc that I will discuss later, but it's important for you to choose the correct postdoc. Choose one that you will be guided by a supervisor that is very invested in your career, that exposes you to different opportunities, conferences. Make sure you publish. This is extremely important. Make sure that you network at conferences, meet other people in your field, see where you can collaborate, do interdisciplinary work together so that you can excel in your career. So now when you start thinking about building your science career, there's a lot of skills that you need to think about. So there's a lot of information on the internet available on developing a research career. There's a book that is published on Elsevier. It's called Career Guidance for Young Scientists. Have a look at that. Also, the Nature paper has a separate section on career advice, and there's some excellent articles there also on, how to build your career, any types of career advice. So have a look at that. Science also has a section for career advice. So have a look at these tools. Have a look at workshops your university or research institute offers, and attend these. Attend every workshop you can possibly and learn. So first of all, you will need research skills like techniques, experimental methods, understanding research designs, approaches, also analysis techniques. Equip yourself with knowledge about different analytical techniques. Visit labs overseas. See what kind of analytical equipment they have. Can you use it? Where can you apply for funding to have these exchange, visit, and learn? Go international. How you monitor your data, also how you evaluate your data, learn statistical analysis techniques, also data management. How will you store your data? If you're working with human subjects, how will you anonymize your data? These are all things that you need to think about. How to choose effective mentor, very important. Writing skills. You need to differentiate writing for publication and writing for the popular media. Develop those type of writing skills. Remember, writing skills in academics is very formal and structured. While you're writing for the popular media, it's more like storytelling is important. What, the who, what, why, when, this becomes important. Right, learn to edit your work, offer your skills as a peer reviewer. You can learn a lot by peer reviewing other people's work. Learn how to effectively supervise. This is important. How to effectively supervise and grow students, how to apply for funding, how to manage a research program, research leadership, how to lecture. Very important, how to present at conferences. What is the difference between presenting a poster? What is the difference between presenting an oral presentation? How do you present at an academic conference? How do you represent at a non-academic conference? How do you tutor, right? Also, time management skills are extremely important. Then what personality characteristics do you need to have, right? Develop your curiosity skills. You need to be curious. Look at your work from different angles. Speak to people from different fields about your work. Speak to your family. You may get different insights from different people, sometimes that may see your work from a completely different angle. Perseverance is extremely important. In research, we will always, papers get rejected. We may not get grants, but that's no reason to sit back and relax. Persevere, keep on going and trying. Be an independent thinker and worker, right? Independency in research is very important. Remember, your supervisor may be extremely busy. So learn about their field, come with proposals and work effectively together with them. Very creative, right? Creativity is extremely important in research. Also, how you write for the popular media. There's also now a trend that is becoming very popular in science is combining art with science to express science using art. You have to be very disciplined, right? This is where the research plan comes in that we'll discuss later. And abide by the rules. What do I mean there? At the very early career research stage, we often don't learn about ethics in science. This is often not taught. We have to learn how to be an ethical scientist, right? We have to learn what is plagiarism, how to avoid this. All of these things, leadership courses in science is also very important because one day you will have to manage your research team. So now, let's look at mentoring. Why is mentoring so important? So mentoring is a symbiotic relationship, and it's aimed at not only advancing your career, but also that of your mentor. It's a learning experience. It's a growing experience. Okay, so before you choose the mentor, you need to think to yourself, make a list. What skills do I need to develop? What are your values? What is your work style and habits? What skills do you need to build? Is there personal skills? Is it academic skills, research skills, grant writing? And then write down these goals for yourself, long-term goals, short-term goals. Also, do you need to attend ethics in research courses, leadership in research courses? Then group them under different headings for your personal. Do you need to learn more about the work-life balance? This is very important. In science, we can get sometimes overwhelmed. So we need to find that work-life balance, taking care of yourself, getting enough sleep, eating a balanced diet, getting enough exercise and balancing your work. right? Building your confidence. This is very important because you have to present one day. You have to present at conferences, at webinars, everywhere, even talk to the media. So build that confidence. And if you need to develop that, write that down. That's something that your mentor needs to help you with. Then also how to set limits. I think sometimes it's difficult to say no, but we also need to learn how to set the limits to our commitments, right? Networking, this is a skill. How do we network? How do we, pitch our research to people? How do we develop our elevator pitch, our 3-minute thesis? How do we entice people? This is what we do. Make it understandable to both someone from an interdisciplinary field, someone from the public. What will be our professional goals? Where do we see ourselves in 5 years? Where will the jobs be? Where do you see yourself? Do you see yourself carrying on in academics, or do you see yourself carrying on in industry? Time management, very important. Writing, administrative skills, learning different methodologies, even writing grants. This is very important. Even fellowship, writing a fellowship. This is a start, right? Now, also when you select your mentor, choose, do you want to work with a female or a male? Be very respectful of cultural diversity. I think one of the blessings of being in research is that we collaborate with people from different countries, from different cultural diversity, and it's extremely interesting to learn about different perspectives, different environments and so forth. Where will your mentor be? Will it be local? Will it be international? And what is their work style? Now, again, coming back to the skills, when you're choosing your mentor, you want someone that promotes your career, right? It must be a symbiotic relationship. It's important that you write first author papers, right? Think about also being a corresponding author. Discuss this with your supervisor or your mentor. Collaboration is important. Do they involve you in collaboration? Do they provide you with opportunities and valuable advice? And do they have previous mentoring experience? Okay, these are all questions that one needs to think about. For example, also, here's 2 differences. Do we choose the senior mentor or the junior mentor? This is a difficult decision because senior mentors maybe have access to more grant funding, while the junior mentor may have more time for you, right? Cultivate that relationship. Agree on a structure, plan meetings, record your meeting, ask questions, listen, be involved, ask for feedback and manage that relationship. Set that goals and be responsive. You have to have regular contacts with your meeting. Then some do's and don'ts for the mentor and the mentee. So as I said before, listen, facilitate, be active, learn. Then also be aware of conflict. Conflict is a thing that can appear in research. So attend courses on how to effectively manage conflict. This is a soft skill that one also needs to learn, right? Be independent. Then also don't. Be careful of how you take credit or taking over, these kind of things. So that's the do's and don'ts. Then I've already mentioned that about conflict. It's important to develop also that soft skill, how to effectively manage that, how to avoid that, and how effectively to resolve that. Now, once you have the mentor, you must think of the plan. What is my research plan, right? You have to come to your mentor or your supervisor with the plan, but you can also ask them. Now, why do you need to create the plan? You need to create the plan for the 1 year, the 2 year, the 3 years, or normally the 5 years. You create the plan for yourself, for your project, and for your professional goals. You will often revisit your plans because something unforeseen may happen, like the COVID pandemic, or there may arise even more opportunities, conferences that you may want to fit into your research plan. You need to think, what would you like to accomplish in your plan? What is your goals, your vision, your objectives? Be honest with yourself. Can you achieve all of this? right? And this is also a way when you set up your research plan to show your mentor or your supervisor to show that you have independent thinking skills. You can also use what's commonly called is a Gantt chart to plan your milestones, your objectives. And in this type of plan, you will have your long term, your short term, and you will also have your experimental research plan, when you will be publishing, when will you be attending conferences, and how you will disseminate your work, and when, by when. You have to put deadlines for this. Right, so you include when you will be applying for grants, your research methods, that type of background, when you will publish. If you're more senior, you will include teaching as well, and also more about community service, interacting with the public, policy, that kind of thing. So these are all things that you need to think about. So remember also, productivity is never an accident. It is always the result of a commitment to excellent planning and a focused effort. Remember that. Right, now, even before you start your plan, it's important to work on a topic, to think about what you're actually going to do. So attend conferences, see what's hot and trending in your field, what's applicable, what addresses the sustainable development goals, search the literature. Look at recent reviews, use Google Scholar, Science Direct, Scopus, PubMed, and very important, use the correct search strings and keywords. And like I said before, choose something that you are passionate about. And normally libraries have a lot of workshops on how to search the literature. Try and attend them, or ask a librarian if you struggle to set up search strings or keyword. Also, combine your literature search using both Google Scholar and others as well, because some websites may not pick up specific information. So let's look at the postdoc, right? This is more than just a research job. You want to make the most of your postdoc. Take advantage of this period in your life, attend workshops, go international, go to conferences, network, and publish, publish, publish. Okay, here's some pros and cons of the postdoc. All that I can say here is that you have to do a postdoc under a mentor that really is invested in developing your career. And also, you don't want to stay too long in this phase. So you want to go to good universities, learn valuable skills, and then come back and apply them home. This is some success factors. I'm not going to go into great detail about that supervisors consider as success, success factors for a postdoc, and what postdocs themselves consider as successful, getting a grant, being able to network, to get mentoring, valuable mentoring, and so forth. Right, so let's look at the academic versus the industrial career. So choosing between the two. What's also important is one can also collaborate with industry. That's also very important. So university is mainly focused on basic research, where industry is focused on applied research. University is to advance the knowledge. Industry is to increase profit. Industry is more about a profit and a product, where university is more knowledge-based. Right, so the CV. Remember, there's a difference between your academic CV and your CV for industry, right? The CV for academia is more on what you have already achieved, your scientific credibility, where industry is more of how your achievements can be applied and which skills you attained. So when you are, planning your career, like I said, there's a whole lot of things to think about. These are just a few that I've touched on now. But like I've mentioned before, the writing skills, publishing skills, presentation skills at conferences, developing your elevator pitch, networking, attending conferences, how to collaborate, how to work with the media, also how to work with policymakers. This is also an important skill to learn. How to manage your time and mental health. how to be a responsible researcher, ethical researcher, know how to produce high quality data and how to manage that data, how to be a good leader. Then there's also the soft skills, the personal awareness, creative thinking, problem solving, conflict solving. And it's also very important to get involved in community outreach, popularizing science among, primary school children, high school children, show and share your science with the public so that they can see the importance of science, that they can start to trust sciences. Okay, so all these things, make a list for yourself, decide where you want to develop yourself, make the plan, choose the correct supervisor, do the great postdoc, and then keep perseverance. Passion is very important, and hard work. Now we get to acknowledgements. I mean, there's a whole lot of people that have really helped me to get where I am today. I'm not going to mention names in case I leave someone out, but I think what's very important in a science career is support from family, my partner, friends, your supervisors, your mentor, my current mentor. There's a whole lot of, I'm now currently with the UNESCO chair in nanosciences. Prof. Maza is my lead. And I mean, all these people, I really wish to thank them. It's all because of them that I'm here today. So thank you very much for the opportunity. I hope you enjoyed it. And I hope I kept to time because I usually talk too much. And so I'm going to stop here now. Thank you very much.
Thanks a lot, Karen. We have 2 minutes to return to the main session, but I think it's fantastic to see your motivation, really,
Okay.
and how to help others to deal with these challenges on the path of developing a science career. But I can open the floor if anyone has quick questions or thoughts to what Karen has presented here this evening.
Karen, I wonder if you don't mind to give a quick ABC of an elevator pitch.
The elevator pitch, well, there's a difference between the elevator pitch and the 3-minute thesis. And I remember reading up a lot about this in the past. So having your elevator pitch is like when you're standing in the elevator with someone, you need to convince them why your research is so important, right? What's the applications of this? And you need to use language that is understandable. It shouldn't be too long because science can sometimes be very complicated. So you need to have it short and sweet. And, when you also talk about your research, either to a academic and also to a non-academic audience, it's important to, sound excited about what you do, because this also comes across, this also, entices them to be interested in your work as well. What some people use also in their, when they talk about their work is storytelling, bringing elements of how your science links or can help the public. But there's a lot of literature on, developing a good elevator pitch. So if you want to go more into that detail, go through the literature, have a look at that. I mean, I myself, I'm still learning. I must, this of working with the media and really popularizing your work is very important. I think this is a skill that all of us must really learn as we go along, because I think as in science, we tend to be in the silo and we're so much involved in our work. It can be so complex at times. And when we're talking to, the media, we need to really make it understandable and relevant. Where does the application lie? Does the data support that, etc.? I hope that answers your question.
Thank you very much.
Thank you.
And of course, you have to finish that speech before the elevator stops.
So any other questions?
Any other question? Please feel free to unmute yourself. I think you have the right to do that if you want to ask any question.
Prof. Bright, you can also distribute my email in case people want to, ask questions that may
Sure.
come up later.
Yeah,
Then they can
sure,
just
no problem.
contact.
I will do that. Thanks
Okay.
for the permission.
Okay.
All right, I will leave you here and go to the main session, and of course, I will call you back in a short while.
Okay. Thank you very much.
Yeah, thanks very much, Karen. I appreciate it.
Most welcome.
And while you have time, I'm wondering if you encounter an abusive mentor of sort who's just all about himself, how do you disentangle without ruining your own work or career?
Oh, this is a very, very difficult issue to answer, because there's a lot of examples actually shared by young scientists. You can read about this, I mean, in various blogs and things like this, where the postdocs have been used as a type of technical assistant. And this should be avoided at all costs. The postdoc is there to build your career. It's very important. You have to build your career. You have to have first author papers, you have to attend conferences, and you have to have your own research. And often dealing effectively with this is very difficult, because you are sitting in a situation where you don't want to compromise your career. This can be, a difficulty. So it's best to talk with a senior person, your mentor,